We're going to take a look at arc length and sector area. Consider the circle below. If the radius is 6 inches, calculate the area of the shaded region. So the radius is 6 inches. We know that the area of a circle has the formula pi r squared. So if we wanted to find the area of the entire circle, we would take pi and multiply it by r squared. So 6 squared is 36. So the entire circle has an area of 36 pi square inches, which of course we could type into the calculator to approximate. But because this angle right here is pi over 2, I know that that is 1/4 of the entire way around the circle because there's 2 pi radians in a circle. So that should mean that this area here is exactly 1/4 of the area of the entire circle. So if we take 36 pi and divide it by 4 to find 1/4 of it, we would get 9 pi. So the area of this sector of the circle is 9 pi square inches, or if we wanted to approximate that, that is about 28.3 inches squared. What is the length of the arc intercepted by the central angle? So the arc length that we're talking about is this right here. So this distance around the circle from this point to this point. And oftentimes we use S to denote arc length. Well, let's think about what is the distance around the entire circle. We know that as circumference, which we know is 2 times pi times the radius. So again, since the radius is 6 inches, this would be 2 times pi times 6, or 12 pi inches. But this is the entire distance around the circle. So again, since pi over 2 is 1/4 of the circle, we can say that this arc length is 1/4 of the entire circumference, which means I could take 12 pi and divide it by 4 and get 3 pi. So the length of this arc is 3 pi inches, which is approximately 9.4 inches. So we're going to utilize this to calculate the specific formula for arc length and sector area. So here we have a picture of a circle with radius r. This angle here is theta radians, and we are calculating this arc length, which we call s. So a few questions to get us started. What is the circumference of a circle? The formula for circumference is 2 pi r, or you could also say diameter times pi. How many radians are in a whole circle? We know that there are 2 pi radians in an entire circle. So both of these are statements about an entire circle, but we found out in our example before that we can use a proportion here, right? Whatever the ratio is of this angle to the entire circle is equivalent to the ratio of this arc length to the entire circumference. So we can write that formula. So we're going to set up our proportion representing the part to whole relationship for the angle measure. So the angle measure, the part is theta, and the whole is 2 pi radians. And that should be proportional with the part to whole relationship of the arc length versus the entire circumference. So the arc length is S, and the entire circumference is 2 pi r. So we want to solve for S in order to get our arc length formula. So we do that by cross products. So S times 2 pi will equal the other cross product, which is theta times 2 pi r. So the first thing is, if I were to divide both sides by 2 pi to isolate S, the 2 pi's would simplify here, leaving arc length S equals, again, the 2 pi's would simplify over here, and we would be left with theta times r. So the arc length is equivalent to theta times the radius. One thing that's important to keep in mind is that theta is in radians. If we were talking about a degree measurement, then our formula would have to be adjusted. Let's talk about sector area. So again, we have this sector here, which is represented by the central angle theta, and our circle has a radius of r. So what is the area of a circle? We know that this is pi r squared. And how many radians are in a whole circle? That would be 2 pi again. So we know that the area here is the same ratio of the entire circle's area as this angle theta is to 2 pi. So the part to whole relationship, we have theta over 2 pi equals the area of the sector compared to the area of the entire circle, pi r squared. So if we want a formula for sector area, then we can go ahead and solve again using cross products. So area times 2 pi will equal the other cross product, theta times pi r squared. So to isolate area, we want to divide both sides by 2 pi. So area will equal theta, the pi's are going to cancel, r squared, and we'd have divided by 2, which you could keep this way, or you could also write it as 1/2 theta r squared. So whichever way you would prefer to write it is completely fine. So we could say that area is theta r squared divided by 2, which is also equal to 1/2 theta r squared. And again, theta is in radians, right? We don't want it to be in degrees. So now we can look through a few examples to practice this. The key here is keeping in mind that theta must be in radians. So number 1, a central angle theta in a circle of radius 4 meters is subtended by an arc of length 6 meters. Find the measure of theta in radians. So let's picture what this looks like. If you have a circle and we have a radius that is 4 meters, and it tells us that we have an arc length of 6 meters. So that means that this distance here is 6 meters. So we're looking for what this angle is right here, which would be theta. Well, we know our formula is arc length equals theta, which is in radians, times your radius. So our arc length is 6. We're looking for theta, and our radius is 4. So to solve for theta, we can divide both sides by 4, which means theta equals, if we simplify 6/4, that would be 3 over 2, or 1.5 radians. Find the length of an arc of a circle with radius 10 meters that subtends a central angle of 100 degrees. So that means that we have this situation here where the radius is 10 and the angle is 100 degrees. Now, because our angle is in degrees, that's the first thing that we have to deal with. We need to convert 100 degrees into radians. So we're going to multiply this by pi over 180 degrees, which means that we would get 100 pi over 180 radians, and we can simplify that to 5 pi over 9. So this angle here is 5 pi over 9 radians. So our arc length formula is radius times theta. So our radius is 10, oops, and we want to multiply by 5 pi over 9, which simplifies to 50 pi over 9, and this would be in meters. But we might want to simplify that or at least approximate it. So if we do 50 times pi divided by 9, we get about 17.5 meters. Number 3 looks at area. So it says find the area of a sector of a circle with central angle 60 degrees if the radius of the circle is 3 meters. So remember that the area formula is theta times the radius squared divided by 2, or 1/2 times the theta times radius squared. So either equation is going to work. 60 degrees, we need to convert into radians. We know that 60 degrees is equal to pi over 3 radians. So we're going to use that. So 1/2 times pi over 3 radians times our radius squared. Well, 3 is the radius, so 3 squared is 9. And if we simplify that, we would get 9 pi over 6, which would be 3 pi over 2. And this would be in meters squared. But if we approximate that so that it's a number that we can work with a little bit better besides 3 pi over 2, this would be approximately 4.7 square meters. And last, a sector in a circle of radius 25 feet has an area of 125 feet squared. Find the central angle of the sector. So if we utilize that area equals theta r squared divided by 2, we can substitute 125 in for the area. So area equals theta times our radius is 25, so 25 squared divided by 2. So we need to isolate theta. The first thing I'm going to do is multiply both sides by 2. So 250 equals theta times 25 squared is 625. So to isolate theta, we're going to divide both sides by 625. So 250 over 625, and remember this is in radians, but we can simplify 250 over 625 is 2/5. So you could say it's 2/5 or 0.4 radians.